A warm good morning to my dear friends. So today we are going to see the topic of resolution of forces. So what do you mean by resolution of a force? The process of replacing a force system by its components is called resolution. For example, there is a force of 7 Newton acting on a particle at an angle of, it acts on the particle at an angle of 37 degrees with respect to the horizontal axis. Now, I want to resolve this force into two components along the x and y direction. So, if you want to resolve a force along its x and y direction, then the component of the force along the x direction is given by magnitude of the force into cos angle made by the force with the horizontal axis. Similarly, if you want to determine the y component of the force, then magnitude of the force into sine angle made by the force with the horizontal axis. That means Fx is equal to F cos theta and Fy equal to F sin theta. So for in this particular case, the angle made by the force with the horizontal axis is 36.7 degrees. Though naturally the Fx will be equal to 7 into cos 36.7 and Fy will be equal to 7 into sin 36.7. So the general equation to resolve a force along its x and y direction is nothing but Fx equal to F cos theta and Fy equal to F sin theta. The composition of forces. What do you mean by composition of forces? The process of replacing a force system by its resultant is called composition. So the resultant of a pair of concurrent forces can be determined by use of a parallelogram law, which states that if there are two forces acting on a particle and if it needs to be replaced by a single force called the resultant, it can be done by constructing a parallelogram with the two forces as the sides of the parallelogram. Then the diagonal of the parallelogram will be representing the resultant of the two forces. Then the diagonal of the parallelogram will be representing the resultant of the two forces. For example, in this particular case, we can see F1, F2 are the two forces. So these two forces are now made to represent two sides of a parallelogram OA and OB. Now I am constructing a parallelogram OBCA. Now OBCA forms the parallelogram with OA and OB being the sides of the parallelogram. Now the diagonal which joins the points O to C of the parallelogram will be representing the resultant of the two forces. So now if there are a single force, it can be split into two components along its x and y direction. Similarly, if there are two forces acting, the result it can be replaced by a single resultant by applying the parallelogram law of forces. Now we will see this with an example. You can see this is a screw I which is subjected to two forces F1 and F2. You have to find the magnitude and direction of these two forces. So the force F1 is having a magnitude of 100 Newton and F2 is having a magnitude of 150 Newton. So F1 is making an angle of 15 degrees with the x-axis and F2 is making an angle of 10 degrees with the y-axis. Now we will find the apply the parallelogram law to determine the magnitude of the two forces. So which states that F resultant of two forces equal to Fx square plus Fy square minus 2 Fx Fy cos theta. Now 100 square plus 150 square minus 2 into 100 into 150 into cos of the angle. So cos theta. So what is the theta of the resultant? So how to find the theta? So to find the theta, applying the law of sines. So 150 by sine theta, that is 150 by sine theta is equal to 212.6 divided by sine 115. So from this we can find the value of theta is 39.8 degrees. Now here the resultant is making an angle of 115 degrees. That we can see it from this figure. Now this angle is 15 degrees, this angle is 10 degrees. Now I am constructing a parallelogram here with the two sides. So 115, 150, this is the resultant R. So now this angle is 10 degrees. Now this angle is 15 degrees, this angle is 15 degrees. So we get this angle as 115 degrees. So this is a typical example of the application of resultant of two forces using the parallelogram law.